Okay students, this is Mallikarjun Pidugu, Faculty of Chemistry, Narayana IIT Academy, and I have been working with Narayana IIT Academy for the last 20 years, and today I have an opportunity and privilege to teach you this particular chapter called Haloalkanes and Haloarenes. In this particular chapter, I am going to handle these aspects: classification of alkyl and aryl halides basing on different aspects, nomenclature of alkyl and aryl halides, isomerism in alkyl and aryl halides, methods of preparation of different alkyl and aryl halides, physical properties, reactivity of different alkyl and aryl halides, and chemical properties. Okay, now I will start with the definition of haloalkanes and haloarenes. So these are the compounds obtained by replacing one or more hydrogen atoms of hydrocarbons with halogen atoms. So these are the compounds which are obtained by replacing one or more hydrogen atoms of hydrocarbons with halogen atoms. So you can simply define these things as halogen derivatives of hydrocarbons, which may be aliphatic hydrocarbons or aromatic hydrocarbons. So you can call these things as halogen derivatives of hydrocarbons. Now coming to classification of haloalkanes or haloarenes, the classification can be done on different bases. The first thing is classification basing on number of halogen atoms. If one hydrogen is replaced by one halogen atom, we will get monohaloalkanes. If two hydrogens are replaced by two halogen atoms, we will get dihaloalkanes. If three hydrogens are replaced by three halogen atoms, we get trihaloalkanes. The example is, this is monohaloalkane, where X is fluorine, chlorine, bromine or iodine. X can be anything. This is obtained by replacing one hydrogen of methane with one halogen atom like fluorine, chlorine, bromine, iodine. Now, if two hydrogens of an alkane are replaced by two halogen atoms, it is called dihaloalkane. If three hydrogens of an alkane is replaced by three halogen atoms, it is called trihaloalkane. So this classification is made on the basis of replacement of hydrogens with halogens. If one hydrogen is replaced by one halogen, it is called monohaloalkane. If two hydrogens are replaced by two halogens, it is dihaloalkane. If three hydrogens are replaced by three halogens, it is trihaloalkane. Now, the second type of classification is based on type of CX bonding, that is whether the carbon to which the halogen attached is sp3 hybridized or sp2 hybridized. We have sp3 CX bond, sp2 CX bond. The sp3 CX bond compounds are alkyl halides, allyl halides, benzyl halides, sp2 CX bond based classification, vinyl halides, aryl halides. And the type of the hybridization of the carbon atom sp3 carbons and sp2 carbons we know. On the type of the hybridization of the carbon atom and the halogen atom attached, we can say that sp3cx bond type of compounds, sp2cx bond compounds. sp3cx bonds, alkyl halides, allyl halides, benzyl halides. In these, the halogen atom is attached to an sp3 carbon. Vinyl halides and aryl halides, in these the halogen atom is attached to sp2 carbon. Now let us take up examples. Alkyl halides. The alkyl halides are again three types: primary alkyl halides, secondary alkyl halides, tertiary alkyl halides. In primary alkyl halides, halogen atom is attached to a primary carbon. What is a primary carbon? Carbon attached to one carbon is called primary carbon. So I will take this one, CH3 CH2Cl, it is called ethyl chloride. In secondary alkyl halides, the example is isopropyl bromide, where the bromine atom is attached to a secondary carbon. Secondary carbon means the carbon attached to two other carbon atoms. Tertiary alkyl halide, tertiary butyl iodide, where the iodine is attached to a tertiary carbon atom. Here halogen attached to primary carbon, here halogen attached to secondary carbon, here halogen attached to tertiary carbon. That's why this is called primary alkyl halide, this is secondary alkyl halide, this is tertiary alkyl halide. Here alkyl halide means alkyl group is ethyl, halide is chloride, so it is ethyl chloride. Here the alkyl group is isopropyl and halide is bromide, so its name is isopropyl bromide. This is called tertiary butyl iodide, because iodide is attached to a tertiary carbon. So alkyl part followed by halide part, ethyl chloride, isopropyl bromide, tertiary butyl iodide, alkyl attached to halide, alkyl halide, ethyl chloride, isopropyl bromide, tertiary butyl iodide. Now after alkyl halides, we have allyl halides. What are allyl halides? What is an allyl carbon? That is important for us. The carbon atom which is attached to vinylic carbon, double bonded carbon, is called allyl carbon. I will show you CH2 double bond CH. This double bonded carbon is called vinyl carbon, and carbon attached to vinyl carbon is called allyl carbon. Here this is allyl group attached to something like bromine, so it is called allyl bromide. Here bromine attached to a carbon which is attached to a vinylic carbon, so this is primary allyl bromide. You can call primary allyl halide. Now I can give you another example. CH2 double bond CH, single bond CH, CH3 Br. This is allylic carbon attached to two other carbons. That's why it is a secondary allyl bromide, because this allylic carbon, this is allylic carbon. Why it is allylic carbon? This carbon is allylic carbon because it is attached to a vinylic carbon. Any carbon which is attached to vinylic carbon is allylic carbon. So this is allyl, and this allylic carbon attached to two other carbon, that's why it is secondary, that is secondary allyl bromide. Don't worry about the naming, we will discuss about the naming in a different session. And one more thing we can get is a tertiary alkyl, tertiary allyl halide. This is the carbon which is attached to vinylic carbon, so it is allylic carbon. Allylic carbon attached to three carbons, that's why it is tertiary. This is tertiary allyl iodide. I will tell you once again, this is primary allyl halide, this is secondary allyl halide, that is tertiary allyl halide. Here the double bonded carbon is called vinylic carbon. This is vinylic carbon, and carbon attached to vinylic carbon is allylic carbon. Since allylic carbon is primary, it is primary allyl halide. Here the allylic carbon, this is the vinylic carbon, and carbon attached to this is vinylic carbon. Double bonded carbon is vinylic carbon. The carbon attached to vinylic carbon is allylic carbon, and here the allylic carbon is attached to secondary, it is attached to two other carbon. That's why it is secondary allyl carbon. To the secondary allyl carbon, bromine attached. So that's why it is secondary allyl bromide. Here the allylic carbon is tertiary as it is attached to three other carbons. That's why tertiary allyl iodide. So like that we can say, after allyl halides, benzyl halides. In benzyl halides, the halogen is attached to benzylic carbon. What is benzylic carbon? Carbon atom attached to benzene ring is called benzylic carbon. This is benzylic carbon. Carbon attached to benzene ring is benzylic carbon. So this is benzyl bromide. Here it is primary because it is attached to only one carbon. This is primary benzyl halide. This is secondary benzyl halide. Look at this. This is also a benzylic carbon which is attached to this carbon, two carbon. That's why secondary benzyl halide. If the benzylic carbon is attached to three other carbons, it is benzyl iodide. This is benzyl bromide, primary. This is secondary benzyl halide. This is tertiary benzyl halide. Here this carbon is benzylic carbon. Here this carbon is benzylic carbon. Here this carbon is benzylic carbon. Bromine attached to primary benzylic carbon. Bromine attached to secondary benzylic carbon. Iodine attached to tertiary benzylic carbon. That's why primary benzyl halide, secondary benzyl halide, tertiary benzyl halide. Let us see classification basing on sp2CX bond. Here the halogen atom is attached to an sp2 carbon atom. In that, the first thing is vinyl halides. In vinyl halides, the halogen atom is attached to vinylic carbon, that is CH2 CHX. What is vinylic carbon? A double bonded carbon is called vinylic carbon. This is the vinylic carbon to which the halogen is attached. So here the halogen can be fluorine, chlorine, bromine, iodine. Now this is also vinylic carbon, double bonded carbon to which the halogen is attached. So these are the vinyl halides where the halogen is attached to the vinylic carbon. So this is one class of alkyl halides or halogen derivatives. The other one is aryl halides. In aryl halides, the halogen atom is directly attached to the carbon atom of the benzene ring. This is the benzene ring. One of the hydrogens of benzene are replaced by halogens. Fluorine displacing hydrogen of chlorobenzene, bromobenzene, iodobenzene, fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. Here the halogen atom is coming in place of the hydrogen of benzene and attached to carbon atom of the benzene ring. That's why if the halogen is directly attached to benzene ring, they are called aryl halides. Now let us take up nomenclature part of the alkyl and aryl halides, that is systematic naming and common naming. So coming to our Iu Pac naming, the alkyl halides are known as haloalkanes. Aryl halides are named as haloarenes. In systematic naming, the halogens are always considered as substituents. They are named as substituents, they are treated as substituents. Let us take up the names one by one. This is obtained by replacing a hydrogen atom of methane with chlorine. That's why it is called chloromethane in Iu Pac system. The common name is alkyl followed by halide, methyl chloride. One of the hydrogens of ethane is replaced by bromine. So this is bromoethane is Iu Pac name, and ethyl bromide is common name or trivial name. Here methyl chloride is common name. So haloalkane is Iu Pac name, alkyl halide is common name. Methyl chloride is common name, chloromethane is Iu Pac name. Ethyl bromide is common name, bromoethane is Iu Pac name or systematic name. If you take this one, how in Iu Pac system it is named, let us see. This is bromine is substituent. Now to name this compound, this is 1, this is 2, this is 3. Longest chain is 3 carbon chain, so it's propane. On the second carbon atom you have bromine. So you can call it as 2-bromopropane. 2-bromopropane is Iu Pac name, and common name is, this is a isopropyl group attached to bromine. That's why it is called isopropyl bromide. 2-bromopropane, isopropyl bromide. 2-bromopropane is Iu Pac name, isopropyl bromide is common name. We'll take up another compound. CH3, CH, CH3, CH2, Br. Now here the longest continuous carbon chain is 1, 2, 3, to which you have 2 substituents, one is bromine and one is methyl. This is first carbon, this is second carbon, this is third carbon. Now this is bromo and methyl, 1 bromo, 2 methyl, which comes first in alphabetical order, bromo. So arrange bromo first, 1 bromo, 2 methyl, propane. Now let us take up the name of this compound. Longest chain is this one, 1, 2, 3. On the second carbon you have both methyl and iodines. So it is 2 iodo in alphabetical order, 2 methyl propane. Let us take up another compound. Friends, I would like to get back to this particular compound once again, because 2-iodo 2-methyl propane is Iu Pac name, and common name is, this is tertiary butyl group. That's why it is called tertiary butyl iodide in common system. And about coming to this particular compound, the longest continuous carbon chain is this one. On the first carbon you have bromine, on the second carbon you have 2 methyl groups. So its name is Iu Pac name, 1 bromo, 2, 2 dimethyl propane. And in common system, this is Iu Pac name. In common system, this is called neopentyl group, alkyl halide. So neopentyl bromide. Neopentyl bromide is common name. Now, so let us take up this compound which has some unsaturation also. When you take this compound, halogen is a substituent and halogen is given less priority than the unsaturation. So unsaturation is given more priority. So when numbering, the first number goes to the carbon having unsaturation. This is second, this is third. Now its name is 3-bromopropionine. This is Iu Pac name, and common name is propyl bromide, allyl bromide, allyl group. Because this is vinylic carbon, carbon attached to vinylic carbon is allylic carbon, to the allylic carbon bromine is attached, hence it is called allyl bromide. 3-bromopropionine or allyl bromide. Now let us take up another compound of this type. We have a triple bond, so it should be named as an alkyne. It is a iodo substituted alkyne. Now the preference must be given to the triple bond when numbering. In this direction 2, 3, 4, in this direction 2. So from right to left you have to number it in this fashion. So it becomes 4, 4 dimethyl 5 iodo. Arrange them in alphabetical order. Now let us take up the Iu Pac name of this compound. This is a ring, cyclohexane ring, in which a double bond is there. This is 1-bromo cyclohexene. 1-bromo cyclohexene. If you take this compound, you have a ring which has only 3 carbon atoms and straight chain has 5 carbon atoms. So it should be named as a open chain compound. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. From both sides, when you number from left to right, this is 1 and 4. When you number from right to left, it is 2 and 5. So it is bromo, it is cyclopropyl. So bromo should get a lower number because they are in the identical positions. So right way of numbering is from right to left. You just ignore this one and take number from right to left, because from left to right and right to left you are getting same set of locanes as 2, 4, 2, 4. When you have same set of locanes, you should give priority to the one which is coming first in the alphabetical order. So now it becomes 2-bromo, 4-cyclopropyl. These are not the correct numberings. Left to right is not correct numbering. Right to left is correct numbering. Then only bromine will get the lower priority. So it is called 2-bromo, 4-cyclopropyl pentane. Now we will take some aryl halides. This is called bromobenzene in Iu Pac system. If 2 bromines are there, it is called 1,3-dibromobenzene, because it is first carbon, second carbon, third carbon. Clockwise direction 1,3, anti-clockwise direction also 1, 2, 3. 1,3-dibromobenzene. It is Iu Pac name. Coming to common name, its common name is meta-dibromobenzene. This is 1,3,5. Trichlorobenzene is Iu Pac name. Systematic name is symmetrical trichlorobenzene is common name. So systematic name 1,3,5 trichlorobenzene. Trivial or common name is symmetrical trichlorobenzene. Now we have another important class of nomenclature here. Whenever 2 halogens are present on the same carbon atom of a carbon chain and adjacent carbons of a carbon chain. Suppose if 2 carbon atoms are on the same carbon atom of the carbon chain, so this is an important class of compound where we have 2 halogens on the same carbon atom. Here both the halogens are on the same carbon. If 2 halogens are on the same carbon, they are called geminal dihalides. Geminal means twins. In common system, the geminal dihalides are named as alkylidin halides. Alkylidin halides. So here, if you take this compound CH3CHCl, 2 chlorines on the same carbon, 2 carbons are there, that's why it is ethylidin chloride. That is the common name. Don't worry about the Iu Pac name. This is not the Iu Pac naming, this is only common naming. Here both halogens are on the adjacent carbon, they are called vicinal dihalides. In common system, they are named as alkylin dihalides. That is ethylene dichloride, because 2 carbons are there here for CH to Cl, CH to Cl, ethylene dichloride. So with this, we have completed the nomenclature part of alkyl and aryl halides.